In this video, I would like to talk about typical magnetic flux density. In earlier videos, I have explained how we could actually measure flux density. For example, if I have, let's say, a piece of magnet with the north pole here and the south pole there, and if I have magnetic field that comes out from the north pole, I can measure this field. If I say connect a piece of wire here, let's say to a battery. Connect a piece of wire to a battery. Okay. Now, let's see. I would like there to be a magnetic force that pushes downwards when this magnetic field goes through the wire. So let's use our left hand. Let's use Fleming's left hand law to determine what sort of direction this current should be. Right, the field should be pointing in the direction of our first finger of our left hand. Okay, and the force should be downwards. So therefore, we should have a current in this direction. So this means that I should have a battery connected this way with the positive pole on this side. So this is how we might connect, set up an experiment to measure the magnetic field, because if let's say the length of this wire is L, then the force is simply related to the magnetic flux density by VIL. And all we need is to put a weighing scale below this wire, and we can measure the force pressing down on it. And then we can use this formula to solve for the magnetic flux density. So we have an idea of how to measure it. And today, with modern technologies, there are also other ways. There's something called a Hall effect device, which is a semiconductor material that can also be used to measure magnetic fields. I shan't go into that. So for now, the main thing is that I want to be sure that there's actually a way we can measure magnetic flux density before I go on to talk about the kind of typical field strength, that magnetic field that we might actually see around us. So now that we are sure we can actually measure it, let me write down some typical values that has been measured by people. Now, these are numbers that I found when I Google using these words, exactly these words, typical magnetic flux density. And what I found on Wikipedia are these values. Okay, let me start by writing this down. The human brain. Now, who would imagine the human brain actually produces a tiny magnetic field? I have no idea how, but apparently the magnetic field given out by the human brain is of the order, that means roughly within 10 times, maybe. That's what we mean by that's what we mean by order of magnitude. If we say order of magnitude in physics, we mean within 10 times of that. So what I'm writing down here are numbers that are orders of magnitudes. So it's actually about 1 picocoulomb, the magnetic field, the magnetic flux density coming out of the brain. Now, what is picocoulomb? You might, if you remember my very first video, I think about or two about units and prefixes. Pico means pico means 10 to the power of minus 12 of a Tesla. So that's a tiny strength, extremely weak field. And actually, we would not be able to measure it using this instrument. There has to be another kind of instrument. I might as well write it down. This is the simple setup for measuring magnetic field. There are other more high-tech meaning very sensitive instruments. So one is called Hall probe. Just in case you like to look this up yourself. There's another one called squid. Now squid, not as in the animal or living thing, but it's a special kind of superconducting instrument. So these are very sensitive devices that can be used to measure such extremely weak magnetic field. So the human brain, right, has that kind of order of field. So that is coming out from all of our brains. So it's kind of familiar enough, even though we don't think about it. Now the other very familiar field, which I think is really quite obvious if you have ever used a compass, is the Earth's magnetic field. It's the Earth's magnetic field. Now the Earth's magnetic field, you might have an idea that the Earth itself is like a giant magnet. Maybe not a strong one by the time the field reaches us, but the North Pole of the Earth is like South Pole of a magnet. So on different parts of the Earth, we would experience different field strengths, and this is the field on the equator. On the equator of the Earth, it's halfway between the North and South Pole, on the surface of the Earth. There would be a magnetic field strength of about 30 micro Tesla. And micro means 10 to the power of 6. Minus 6. Okay. So this is 30 times 10 to the power of minus 6 of a Tesla. That's the Earth's magnetic field, and this is the field that causes our compass needle to rotate and point towards the north. Right, so this is what makes our compass work. Okay. Now another familiar example is perhaps the everyday magnet that we would use. If you look around us, we might often see magnets that are used to stick things together. When I was little, there are these pencil case with tiny magnets to stick the cover to the case. And I think if you use a refrigerator, I think many refrigerator doors have magnets which stick the door to the frame. Now, there is a kind of a decorative thing that you stick on the walls of the refrigerator. I call this refrigerator magnets. So cute little shapes, colorful, that you can stick on the wall or on the door of your refrigerator just for decoration. Now these refrigerator magnets would have a magnetic flux density, at least very close to the magnet itself, of the order of about maybe 5 milli Tesla. Milli, we know as in millimeters. So that would be 10 to the minus 3. And that's what milli means. So that's refrigerator magnets. Okay. And we do have extremely strong magnets these days for many different kinds of applications. Now, you might have heard of something called MRI. MRI stands for magnetic resonance imaging. And you might have seen this on movies, films. These are big instruments used in hospitals where they scan the bodies and the brains of people to get a picture of the internal organs. So it's a bit like X-ray. It's a bit like X-ray, except that you can, in many ways, see more clearly than X-ray. So that's MRI. Now, MRI uses extremely powerful magnets, and these are of the order of 10 Tesla or so. So you see, 10 does not look like a big number, but in terms of magnets and in terms of our experience, our daily experience, 10 Tesla is a very strong magnet. And it takes a huge amount of electric current to make an electromagnet that has this kind of power. And it also takes very special materials, very special magnetic materials to achieve anything close to this. So that's MRI. And there are also other higher fields that has been produced by people. I shan't go into that. So these are the typical kind of values that we're talking about when we talk about magnetic field, right? These are things that magnetic fields that are around us.